Now here we quickly understand a new type of function which is called as an identity function, and it is defined as f of x equal to x. So that means whatever is the value of x, same is the value of the function. So in other words, the graph will be nothing but the line y equal to x, because y stands for f of x. So it is a line with 45 degrees angle made with positive x-axis, and the line of course passes through the origin, right? And the slope of that line will be 1. So this is the identity function, and this function is used in referring to some properties of inverse of a function. So let us see some important properties related with inverse of a function. The first is inverse of a function is unique and bijective. So that means for every function which is invertible, it will have a unique inverse, that is there cannot be multiple inverses of a function, and that inverse function will also be a bijective function. So basically what we have to understand is a function and its inverse form a mutual pair of inverses. That means say f and g are two functions such that g is the inverse of f, then it also means that f is the inverse of g, alright, and both will be bijective functions, because otherwise the inverse will not exist. Second property is if f is a function from set a to b is a bijective function with the function g defined from b to a as the inverse of f, then the composite function of g of f will be nothing but the ia, which is denoted by, that is nothing but identity function on set A. And similarly f of g will be nothing but ib, which is the identity function on set B. So we have already seen what does identity function mean. So here identity function on set A means that if we take one element of set A and send it through the composite function g of f, then we will get back the same element in the set A, alright, and the similar happens for the composite function of f of g also for set B. Third property says that if f defined from set A to B and g defined from set B to C are both bijective functions, then their composite function g of f, which is defined from set A to C, is also a bijective function, right? And further, the inverse of g of f is equal to f inverse of g inverse. So you see here the order was gf in the original left hand side, but while taking the inverses the order changes, that is f inverse comes first and then g inverse while writing the right hand side. Okay, now moving ahead, the next property is the graphs of y equal to f of x and y equal to f inverse of x are symmetrical about the line y equal to x. So as an example, let us consider that we have a logarithmic function. We know that the logarithmic function looks like something like this, right? And the line y equal to x, let us denote it as in green as shown here. Alright, so here we have say log x to the base a. Say a is positive, a is not equal to 1, but a is greater than 1. So the graph will look like this. Now we know that the inverse of log, or the opposite process of logarithm, is nothing but the exponentiation. So therefore here we will get the exponential function like this. So here you will have the exponential function of a raised to x for the same value of a, and you will see that these two graphs are the mirror images of each other in the line y equal to x, right? So this is a very important fact regarding the inverse functions, right? Now let's go ahead and Here is the procedure to find the inverse of a function. That means what do we actually do to find the inverse? So firstly we consider the given function as, say, y, that is we write y equal to f of x. Then we rearrange this particular equation into x expressed as some function g of y, alright, and this particular function g is nothing but the inverse of the original function x. So therefore here also we see that we have already seen this particular procedure earlier, and based on this now we will solve some of the examples. Now here function f is defined from set of reals to set of reals, and it is given as f of x equal to 3x minus 1 upon 4. Then find the inverse of f. Alright. So as we have seen, firstly let us write y as f of x, so that is 3x minus 1 whole upon 4. Now we have to do all the adjustments and transformations to bring x in terms of y. So therefore by cross multiplication we have 4y equal to 3x minus 1, so which gives us 3x is equal to 4y plus 1, and hence x is nothing but 4y plus 1 upon 3. Now let's call this particular quantity as some function of y, so therefore we call that as g of y given by 4y plus 1 whole upon 3, and hence this is nothing but the definition of the inverse. So what it means is, if say x is some element in first set and y is some element in second set such that y is the image of x under the function f, then given any y we can find back the original x using the function g, so hence g becomes the inverse function. Now typically while writing the function we use the symbol x, right? So therefore generalizing we can write that instead of g of y we can write it as, say, f inverse of some label x given by 4 times that label x plus 1 upon 3. So now we have to carefully understand that this x which I have written here does not mean the x here, alright. It means the x in the second set, alright, and that gives you the original value in the first set using the operation given, alright. So it is the operation on the reverse path that we must do to get the element in the first set, alright. So therefore the inverse of the function in terms of x is as shown here. Now let's do one more sum based on finding the inverse. If f is a function defined from set of real numbers to the open interval minus infinity to 1, and if it is defined as f of x equal to 1 minus 2 raised to minus x, then find f inverse of x. Now here, although we are given this particular set, we need not worry about why this particular set is given at this step. We will understand the importance of that set once we find the inverse. Alright, so let us first go ahead and write y is equal to 1 minus 2 raised to minus x. So therefore if I bring 2 raised to minus x on left side, we'll have 1 minus y. So taking reciprocal we have 2 raised to x 1 upon 1 minus y. Alright, of course here it is assumed that 1 minus y is not equal to 0, that is y is not equal to 1. Okay? And we can see that the value of 1 is definitely discarded in the second set because it is open interval, so the value 1 is not included for y, right? Alright, and since we want finally x and here we have exponential, so therefore we take the log of both sides to the base 2, so therefore x is given as log of 1 upon 1 minus y to the base 2. So therefore we have expressed x in terms of y. So now therefore we can call this right hand side as, say, some function of y, say g of y, given by log of 1 upon 1 minus y to the base 2. Alright. Now let's confirm why we are given the second set as the closed interval minus infinity to 1. Now if you observe, the function which we found as an inverse is a logarithmic function, and for a logarithm we must have the quantity whose log we are taking as a positive number. So that means we must have 1 upon 1 minus y, a positive number. Alright. Now if we want this as a positive number, then since 1, the numerator, is already positive, it means that the denominator also has to be a positive number. So that means 1 must be greater than y, and that in turn means that y must be less than 1. Now if y is less than 1, it means that y can be any real number less than 1. So therefore y must belong to the interval of all the real numbers which are less than 1 but not including 1. So we will have the open side at 1, and less than 1 we can go up to anywhere up to minus infinity. Alright, and this we see that this is precisely the second set given to us. So that confirms that y will be definitely belonging to this particular set as required. So therefore our final inverse function, which can be written in terms of x now, is f inverse of x is given by log of, now you see, instead of writing in terms of y, we are writing in general in terms of x. So that is log of 1 upon 1 minus x, and the log is taken to the base 2, so therefore it is to the base 2. So therefore finally the answer is this, that's the inverse.